What is the definition of integer? So see, first of all, you have natural numbers, right? Natural numbers are 1, 2, 3, 4, 5. So they are also known as counting numbers, right? So this is natural number. Then you have whole number. Whole number is natural number plus 0. 0 is not a counting number. So when you write whole number, you include 0, right? Then you have integers. Integers is whole number and then all the negative natural numbers. So you have natural number. If you take the negative of natural numbers, you'll get -1, -2, -3, -4, and so on. So if you take integer is negative natural numbers, positive natural numbers, and 0, right? Or whole numbers plus all the negative natural numbers, right? So I mean, what is common among natural numbers, whole numbers, and integer? Is there anything that is in common? So see, one thing that you'll observe between these three, if you have studied the definition, is they all can be represented in a number line. Okay, so say if I give you a number 5, so 5 is an integer, 5 is a whole number, 5 is a natural number as well. So you can represent 5 on a number line. If I give you 0, 0 can be located. So 0 is an integer, 0 is a whole number. So you can represent 0 in a number line, right? And if you have 1, 2, 3, 4, 5, the natural numbers, or say negative integer, right? Say -5. So you can represent -5 in the number line. So if you look at the broader classification of numbers, there are two numbers. One is real, okay? The other is imaginary. Okay, what are real numbers?
Real numbers are the numbers which can be represented on the number line, whereas imaginary numbers are the numbers which cannot be represented on the number line.
So you need a different type of number line to represent imaginary numbers. The conventional number line that we have, it is not going to work with imaginary number. An example of imaginary number is root over of -1, right? Because you cannot calculate this, or say root over of -5. So square root of -5 is an example of imaginary number. Square root of -1 is an example of imaginary number. So say 2 plus root over -5. So you can calculate root over 5, but you cannot calculate root over -5. Okay, so this is an example of imaginary number. So there is no further branch of imaginary number. Then if you come to real number can be of two types. One is rational, right? The other is irrational. What are rational numbers?
The numbers which can be written in the form of P by Q.
P by Q, where P and Q are integers and Q is not equal to 0. Right, so if you take an example, 2 upon 3. So 2 is an integer, 3 is an integer, and 3 is not equal to 0. So it is a rational number. So there is another definition of rational number in terms of decimal. Say for example, if you have a number like this, 0.66. So this is the definition based on fraction, right? So you may be given a decimal number, and you may be asked whether it is rational or irrational. So if I give you a number like this, or say if I give you a number like 0.6, is it rational or is it irrational? Rational, because you can write it in the form of 6 upon 10. Then if you simplify this, you'll get 3 upon 5. Now 3 and 5 are integers and 5 is not equal to 0, so it is rational. If I give you a number like this, 0.6666, it will keep on continuing. So is it rational or irrational? So you can convert it to fraction. Say you can assume x is 0.6666 and so on. So you'll write 10x is 6.66 and so on, right? Then you subtract it. So you'll get 9x is equal to 6, right? So x will be equal to 6 upon 9, right? So again, you'll get P and Q are integers and Q is not equal to 0. So it is rational number. So if you define in terms of fraction, so this is the definition. If you define it in terms of decimal, so see, there can be three parts to it, right? The first part, it cannot be a fraction. Say it can be an integer. Then the second part can be, it is a fraction. And the third part is, it can be a decimal, right? So integers, you now know it is -1, -2, -3, and then 0, then 1, 2, 3. So if you classify integer, you'll get natural number, whole number, and then you can get negative number. But if you look at fraction, so which fractions are rational? The fractions which can be written in the form p upon q, where p and q are integers and q is not equal to 0, right? An example of number which is not rational is root 2. So root 2 is an irrational number because you can write it in the form of root 2 upon 1. So if you look at p, is it an integer? Is root 2 an integer? No, right? So you cannot write it in the form of p upon q. So that is why it is not a rational number, or it is an irrational number. Okay, when you look at decimals, so we saw two cases. The first case, when I gave you 0.6, this case was terminating. And what was the second case? Non-terminating but repeating, right? So if the number is repeating, say, it does not matter whether only one digit is repeating. So if you have 0.63, the same thing repeats. Or if you have 0.796262 and so on, this is also a rational number. Okay, irrational number, if you write it in terms of fraction, for example root 2, which we already discussed, and for decimals it is non-terminating, non-repeating, right? For example 0.63287115 and so on. And then you have pi, right? Pi is an irrational number. You have e is also an irrational number. So when we deal with higher powers, we usually use this notation. So see, for example, pi, the value of pi, if you have an approximate value, it is 3.14, right? If we take the approximate value of e, it will be around 2.71, right? And I mean, if you have used Excel and if you see some larger number, it will be represented, say, 1 into 10 e to the power minus 8, like this. So this is how we used to denote larger numbers. So we'll study these in higher classes. Okay. Now back to this topic. So basically integers, you can represent it in a number line, right? So say if I give you an integer, if we have negative integers, so that means if you want to represent it in the number line, it will be to the left of that origin. And if you want to represent positive integer, it will be to the right of origin, right? If you want to represent 0, it will be at the origin itself, right? So you have positive integers, you have negative integers. So what are positive integers? So you have 1, 2, 3, 4, 5, and so on, right? So they are positive integer. What about negative integer?
Negative integers are to the left of the number line. For example, -1, -2, -3, and so on.
Right. Then you have 0. 0 is neither a positive or negative nor a negative integer, right? So then you have this definition, non-positive integer. What are these? All the negative integers and 0, right? So 0, -1, -2, because 0 is, you also know that 0 is not a positive integer. So when you are writing non-positive integers, so this means integers which are non-positive or not positive. So that will include 0 as well. Similarly, non-negative integer would include 0, 1, 2, and so on.
Fine, that is all we need to know about integers. We'll continue with the properties of integers in the next class.